All right, CNT125, we're looking at our subnetting problems. The previous podcast, I did the first problem in our lab here, this first one up here, okay? I'm going to, in this podcast, show you the third one, because the third one's a Class B. That tends to throw people for a loop, but there's really nothing to fear here. But we'll do it anyway, that way you understand the process on how you would do this. Okay, so they're telling us in this case, they were allocated a private B address to support the IP address needs for the network. To help organize the network, they decided they will need at least six subnets for their network. So right off the bat, we're thinking 6 subnets. 3 bits borrowed would accommodate 8 subnets, 2 extra. So we're probably thinking right off the bat 3 bits borrowed in this case. So I'll put that in here just as kind of a 3 bits borrowed, thinking that's what we're probably going to do. 2 to the 3 is going to give us 8 subnets kind of dealio, okay? Just to kind of get things started. To help, blah, 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 blah. The network number of this network is a 172.16. That indeed is a Class B. So we should be thinking right off the bat, Class B, this stuff right down here. 255.255.00 is the default. Here's our subnet mask in decimal default. That's what I should be thinking, okay? But we already said we're going to borrow 3 bits. So let's go back to this and edit this. If we're going to borrow 3 bits, they would be right here. 1, 2, 3. And my change here is going to become 224. I am now going to have 255.255.224.0. So this is going to leave me 8, 9, 10, 11, 12, 13 bits left. Okay, so we're now going to have 13 bits left for hosts. So if I take a look over here, we're going to have 2 to the 13 left, 2 x to the y 13. If I take a look, actually I'll go over this one right here. If I have 13 bits left, I'm going to end up with 8,192 addresses per subnet. Okay, fine. 8,192 addresses per subnet, of which, how many are going to be usable? 8,190 addresses usable per subnet. Alright, that's what we're going to do. Okay? So, that now becomes 255.255.224.0. Okay. 255.255.224.0. And my bit count is going to become 8, 8, 16, 17, 18, 19. Our bit count will be /19. There is my planning for their network needs, if you will. So now I'm going to take that, and I want to again find out my network numbers, my usables, and my broadcast addresses. So over here, with my Class B, these 2 octets were the host octets, these last 2. So I need to worry about those 2. But I'm going to start simple. I'm going to start with, okay, this is the octet where the subnets, the bits are being borrowed for subnets. So this is the interesting octet. So I'm going to focus on just the 3rd octet right now. This one right here, this octet right here. I'm going to focus on that one, and then I will worry about adding this 4th octet when it's appropriate. So I'm going to look at this octet, and just like I did before, I'm going to zero in on the interesting bit. Well, the interesting bit is this 3rd place. Boom, boom, boom. This 3rd bit I borrowed right there. The 32 place. That is my interesting bit. So my subnets are going to go up by a factor of 32. Very much like the last problem we did. So my first subnet will be 0, obviously. Next one's going to be 32. And they're going to go up by a factor of 32, just like before. 64. 96, and so forth. Okay, 96, 128. All right, I will finish filling these in later. I'm just going to get things started. I'll pause and finish typing, and then we'll finish up our problem. Well, just like before, if this subnet starts at 0 and this one at 32, this one up here has to end at 31. So I'm going to put 31 over here. That is nothing new. This one's going to have to end at 63. This one's going to have to end at 95, and so forth. Okay, this one's going to have to end at 127. None of that is new. Where it's going to change now is right now. I now need to account for this last octet before I get any further. So what I'm going to do is I'm going to keep it simple. If I remember my rules for subnetting, all zeros in the host portion is a network number. All zeros in the host portion is a network number. So I'm going to add on this fourth octet as .0. That's going to make the network portion all zeros, indeed making it a network number. Well, that was easy. So I'm just taking these third and fourth octet now. I did the borrow bits here in the third octet. I'm tagging the fourth octet as 0 to make it a network number. Oh, okay. Well, my other rule on the other end over here is for a broadcast address is all ones in the host portion, right? So I'm going to put all ones in the host portion, or in our case, decimal .255. So this is now going to be my broadcast addresses over here. All zeros in the host portion for network numbers, all ones in the host portion for broadcast addresses. Well, that was pretty easy. Yeah. The usables in the middle, I just have to be smart now. Just like the odometer of your car, when you're driving, the far right number increases as you're driving down the road and increasing in miles. So what I'm going to do now is I'm going to take this 0.0 that I have over here, 0.0, and when I did one more before, I'm just going to do one more in the far right column, if you will, and do 0.1. That'll be the first numbered increment as I drive down the road on my odometer. And the other end of my scheme over here, I have 31.255 over here as my broadcast. I'm going to go one less. Well, one less is 255 minus 1, or 254. So my usables now become 0.1 the whole way up to 31.254. And again, that's accounting for these two octets right here, because we're borrowing the bits and subnetting in this one, but this host octet, these are all host bits to use. So I'm tagging them on. This is the fourth octet. This is the fourth octet. Okay? And I'm just going to use that same scheme the whole way down. 32.1 the whole way up to 63.254. Down here I will have 64.1 the whole way up to 95.254. Alright? I'm going to pause for a second while I finish typing, that we don't have to watch me, and then we'll come back and tackle the ending problem at the bottom. Alright, and I finished filling in my chart here. The whole way down the left, my subnet number is .0. Broadcast addresses, this was the other end of my range. All ones in the host portion, 255s. And then the usables, I'm increasing by 1 from this side, 0.1, 32.1, 64.1. And then on the other end, 31.254, one less. 63.254, one less. The whole way up here, 255.254. So there is my 8 subnets, 1, 2, 3, 4, 5, 6, 7, 8. And in there, the 8,192 addresses per subnet. Because if you think about it, I'm going to go 0.0, 0.1, 0.2, 0.3, 0.255, 1.0, 1.1, 1.2, 1.3, 2.2, 2.1, 2.3, 3.3, the whole way up to 31.255. That's how I'm getting the 8,000 addresses in here. Okay? Alright, if I take a look at the problem at the bottom now, we have an ANDing problem. So we need to AND together the 172, 16, 150 with my subnet mask. Well, we said our subnet mask was 255.255.224.0. So 255, 255, 224.0. And if we remember when we talked the ANDing, 172 ANDed with 255 are all ones is going to yield 172. 16 ANDed with 255 or 16 ANDed with all ones is going to be 16. This is the number that's going to change. 100 ANDed with 224. If I take a look out here, 50 ANDed with zeros or all zeros is going to become 0. There's another one we don't actually have to do. So this is the octet where we did the subnetting, we borrowed the bits, this right here, the interesting octet, that's really the only octet we have to AND, 100 and 224. So if I take 100, convert it over to decimal, 011000100, and I and convert 224 now. So we do 111, 1, 2, 3, 4, 5. If I take a look, I'm going to AND together 0 and 1. That's going to be 0. 1 and 1 is 1. 1 and 1 is 1. And the rest are zeros. So I'm going to end up with 0, 1, 1. I'm going to end up with that. 0 and 1 is 0. 1 and 1 is 1. 1 and 1 is 1. And the rest are zeros. So I'm going to end up with 0, 1, 1. And the rest is zeros. So 64 and 92 is going to give me 96. I'm going to end up with 96 when I AND those together. So I'm ending up with 172.16.96.0. That is my subnet. So if this IP address came into a router, it ANDs it, it's going to get 172.16.96.0, and it knows that's the subnet. It'll look that up in the routing table and know that's where it needs to pass to. If I take a look up here, this should also make some sense. Where's 100.50? There's 100.50. If I take a look, 100.50 is in this range right here. 100.50 is in this range. It belongs to 96.0. There he is. Okay, so there's my ANDing problem. Again, we're doing this because this is how routers are going to make path decisions and decide, and look that up in the routing table and decide where it goes to. This is also a handy trick for dealing with those certification problems. I could zoom in on just this octet and just AND this octet. The other thing they like to ask you is this a usable IP? 172.16.150, and they'll throw a /19 behind it. /19, and I'll say, is that a usable IP? Well, what I could do is take a look at this right here, 224, the /19, 224, 111.0.0.0, and look at this right here and go, this is a combination of ones and zeros in the host portion. I know it's got to be a usable host IP. I don't need to go any further. If this number was all zeros in the host portion, we would know it's a network number. If it was all ones in the host portion, we would know it's a broadcast address, if you will. So there's another sneaky thing to do, another sneaky little trick to do. Alrighty, that is the third problem in our subnetting problems lab. You'll just need to do the second and the fourth one on your own, remembering all those little tips I showed you.